Hello and a very warm welcome to Cognito Key. In the world of electronics, it's all about signals, right? But what do you do when a signal is too strong or maybe just not in the right place? Well, today we're going to look at two really clever circuits that solve these exact problems, the clipper and the clamper.
Now, I know they sound pretty similar, but trust me, in terms of what they do, they are complete opposites. One is kind of like a pair of scissors, carefully snipping off parts of a signal that are too high. And the other? It's more like an elevator, lifting the entire signal up or down to a new level.
So that's the big question, isn't it? How do all our gadgets handle these electrical waves without getting damaged? That's exactly where clippers and clampers come into play. One limits and the other shifts. Okay, let's get into it, and we'll start with the one that does all the trimming.
All right, first up, let's talk about the clipper. And the name really says it all. Its main job is to clip or cut a signal, making sure it never goes past a certain point.
Think of it like a guard for your sensitive electronic components. It sets a really strict voltage limit. Anything that tries to go higher than that limit just gets chopped off, making sure nothing inside gets overwhelmed by too much power. It's a protection circuit, really. So, how does it actually work? It's surprisingly simple. When the positive part of a signal comes along, a little component called a diode opens up like a gate. But this gate has a tiny toll. As the electricity passes, the diode uses up a small amount of voltage. And just like that, this toll sets a brand new maximum voltage for the signal. And you know what's amazing? That toll is super precise. For a standard silicon diode, which is used everywhere, it's almost always exactly 0.7 volts. This means the clipper isn't just randomly cutting the signal. No, it's setting a very specific, very reliable ceiling. Okay, but what about the other half of the signal, the negative part? Well, now the electricity is trying to go the wrong way down that one-way street. The diode basically closes the gate and says, nope, not this way. So the signal has no choice but to go all the way around, passing through completely untouched. Pretty clever, right? So we've seen that the clipper is all about cutting. Now let's completely switch gears and meet its counterpart, the clamper. The clamper has zero interest in cutting anything. Its whole mission is about moving. See, the clamper doesn't mess with the signal's shape at all. It keeps it perfectly preserved. Instead, it just picks up the entire waveform and moves it, either up or down, clamping it to a totally new reference point.
So what's the clamper's secret? It's a component called a capacitor, which acts like a tiny, super-fast charging battery. On the first cycle of the signal, it charges up to the highest voltage. Then, a diode slams the door shut so it can't discharge. Now that stored voltage acts as a new floor, lifting the entire signal up.
And this is where things get really cool. Because you're adding that stored voltage to the incoming signal, you can actually double the peak voltage. It's an incredibly simple but powerful way to make a voltage multiplier.
Okay, so we've met the cutter and the shifter. Let's put them side by side so we can see all the key differences in one quick look.
You can see right away just how different they are. The clipper's function is to limit the amplitude, while the clamper's shifts the DC level. A clipper doesn't need to store energy, but a clamper absolutely needs a capacitor for that. And probably the biggest difference, a clipper changes the shape of the waveform, while a clamper leaves it exactly as it was.
So if you only remember one thing from this entire explainer, let it be this. A clipper changes a waveform shape by cutting it. A clamper preserves the waveform shape and just moves it. That's the core difference.
Now, you might be thinking, this is all just interesting theory. But these two circuits are actually the secret heroes behind so much of the technology we use every day. Let's take a look at where you might find them.
Clippers are everywhere. You'll find them in radio transmitters to prevent distortion, and in your audio gear to get rid of annoying static or noise. They can even be used to take a smooth sine wave and carve it into a sharp square wave. And clampers, well, with their ability to shift and multiply voltage, they are absolutely essential for things like sonar and radar systems. And that's really what it all boils down to. Clipper limits and clamper shifts. Two simple, fundamental ideas that have really powerful and wide-ranging uses in the world of electronics.
So, the next time you're listening to the radio, you'll know that a little clipper circuit is working hard to keep the signal clean. It's pretty amazing, isn't it? What other electronic fundamentals would you like us to break down next? Please do let us know in the comments below.
If you enjoyed this explainer and learned something new, we would be so grateful if you would subscribe to Cognito Key. And of course, don't forget to like this video and share it with someone who might find it useful. Thank you so much for watching.